Welcome to CS 112's Lesson 14.1 Transformations. This lesson is for the University of Idaho's CS 112 dual credit program. Alright, so today, chapter 14, we're talking more artistic transformations, kind of making things a little more artsy than what we've done before. This kind of as always, what we see up here is our kind of our end goal that we're going to be getting to at some point in time. So let's get into it. The first thing that we have is we do have a warm up today, and it looks like this. So try the following code. Pause this if you need to, and and copy down the code. You will kind of notice that it doesn't seem that we have a void setup and void draw. By default, it'll do this kind of over time. And so first, let's go ahead and run this. And I get this, which is simple enough. And then the next kind of step to do, we go back to our program, and I have it kind of in here in the comments of add this line after the first run and see what it does. So just as a reminder, this is what it looks like now. Let's see how it changes. If I push the little play button, what happened? What happened here is we changed stuff a little bit. And what we really changed is the only thing that we actually changed is we changed stroke weight. And you should notice that there is a new term in there. This is this scale term. Um, for the warm-up part, though, what I want you to do is I want you to change the color and the scale of the circles and see what that does. And post a screenshot of your final circles. Again, if you need more time, definitely pause this, test it out, see what happens. Let's go back to the main screen, though. So like I said, today we're going to be talking transformations. Transformations are something that hopefully you've heard about in your math classes. If not, that's totally fine. We'll be talking about them today. Uh, so we've talked about this before, and the coordinate system in processing for some people is a little odd. It's a little weird when actually a lot of times whenever people are thinking about it. And the reason why is that the origin, the place that that everything is based off of, is in the upper left corner. Which, if you think of like your traditional Cartesian coordinate system, it doesn't make any sense. You're like, why are you there? You should be in the center of the screen. And we get that. And it's not convenient all the time to have it in that upper left-hand corner. And so we're actually going to learn how to transform our canvas and able to make our own artistic kind of thing and be able to work with it a little bit more. Uh, so, we just actually already started with this warm-up activity to investigate some of that scale function. We modified it like this. We actually did this part and we got this kind of part and we noticed, hey, actually the stroke weight here changes. It actually matches up. So, uh, the scale factor of 3.5 is the decimal representation of 350%. So the larger circle, so this larger circle that had the really dark line about it, the really dark stroke weight around it, was actually this little circle kind of expanded 350%. So on the first run, we had these two circles, one having a heavier stroke weight, and then later on, we actually have them have the same stroke weight. So this is the same circle, but it's just made bigger. Okay. So scale increases or decreases the size of an object by a given scale about the origin. The vertices are multiplied by a given percent expressed as a decimal value. So, for example, the scale, and we do the percent as a decimal value. So that 3.5 was that 350%. If I did 0.3, it'd be 30%. So it actually would get smaller. And so you can make objects get bigger and smaller. And it's actually kind of important whenever you start thinking about like if you're trying to do something in the distance, or you want to make it appear that something is going into the distance. Nothing about the object changes. It's just its scale or kind of its size does. So this is really helpful whenever you're talking about something like objects, something that you kind of make over and over again, but you want them to appear at least to be at a different distance away from you. Um, so if you want everything to keep that same stroke weight, you simply just do the stroke weight divided by the scale factor. It'll provide you with the same thing. So um, let's go ahead and try this. So we have this ellipse. We're going to keep this the same. Let's do right after scale. Let's make the stroke 255, 0, 0. And if I click the run button, this is what pops up. The second circle still follows everything before it, like in terms of like, oh, change this to this. It's not an exact replica. It's just simply scaled. And that's kind of important to think because you're not making the same exact thing, but you're making things that are very similar. You can even play around with what that scale is, maybe make it 2.1, see if it makes it a little bigger. Um, you'll kind of notice having this as S, the scale as S, makes it a lot easier instead of me changing the scale here and then having to be like, oh yeah, I gotta go change the stroke weight. I can go and do that. Let's try something a little bit different. We haven't done this one yet. And so I know I just was, singing praises about having this as S, but let's change it a little bit. Let's do this. So let's draw an ellipse. Same kind of setup. We're going to do something else. We're going to say 2.8, comma, 0.75. Now I want you to take a second, let me, or kind of talk with maybe your partner, your friends, or kind of mentally to yourself of asking, what is this going to do? Why is this a little bit different? Like how is he changing this? Um, and why not? For fun, let's fill this with some blue. Why? That way we can see what we actually changed. So take a moment. What happened? There we go. I probably didn't show right off the start. What happened um, to our circle? What we can notice is that we're stretched horizontally, horizontal being left and right, but we're compressed vertically. So if you look at our program, when I look at this scale, I see 2.8. Well, that's 280% because I have to change these to a percent. So this is 280%. This is 75%. And so going back and looking at our result, it kind of makes a little bit more sense of saying, oh, this is spread out 280%. It's shortened or it's compressed 75%. Hopefully you're able to get that. Okay, let's go back to our main screen. The other one that we're going to talk about is translate. Translate, like in geometry, or even if you remember kind of graphing on like parabolas or lines in your algebra class, translate moves something, or really not really moves, but shifts left and right, up and down without changing the size. And so translating in processing, the origin is what's translated. It's not the object itself, it's the origin is translated. Uh, translate is additive. Sorry, translate in this term is additive, meaning if I run it once, it will run again, and it will keep kind of going. And this is a little bit helpful, but can also be a little tricky in that you need to kind of pay attention to like, okay, where are we actually at right now? Otherwise, it's really easy for your house to just be completely like skewed about, like deconstructed type thing. So each time the statement's run, the origin uh, is set back to the upper left. So what that means is if you do translate multiple times inside of draw, you're going to be having changes. But whenever you reset draw, or whenever draw restarts, or when it goes back to the top of draw, the origin goes back to the upper left-hand corner. So it doesn't stick there permanently, but it is something that you kind of have to pay attention to, especially if you're doing something kind of like a big, like artistic programming. So let's try some. So let's delete this. Let's do a size of 300. I guess I gotta lift that up. 300. Oops. It's not gonna know what that means. Let's do a rectangle. And we're gonna make it at 10, 15, 50, 20. Oops. 20. Now, let's translate it. Let's translate 20, 40. And probably here, I definitely put a comment just so I can see it and say, hey, this shifts 20 to the right and 40 down. And what it actually shifts is 20 kind of, and hopefully your math or science teachers kind of drill this in your head, 20 what? 20 pixels. And 40 pixels are what moves. That's how far it moves. Let's go ahead and now do a fill, just so we can kind of see what we're changing a little better. Let's make it 255, 0, 0, close it. And we're going to do a rectangle that is exactly the same as up here, so I'm going to go Control C, Control V, and I'm going to push the play button. I'm going to look at what we made. So you can see that our red uh, rectangle seems to be shifted down. It seems to be moved down. We did the same exact rectangle. The numbers are exactly the same, but it's shifted down. It's shifted down specifically 20 to the right and 40 down. This is our new, like, actually, like, you can almost imagine, like, this right here is your new origin. Now, as I said before, draw loops again and again and again, and so you can tell just from this that it's not like just moving forever in this direction. Okay. All right, let's do another one. And we can look at the main screen for this. Rotate. Rotate does what it sounds like it's going to do. It rotates a specific number of radians. You'll remember from prior lesson that we talked that processing does everything in radians. It doesn't deal with uh, degrees. Can you make it degrees? Yes, you can. But then you have to go and do that whole like kind of radians conversion type stuff. You can give this by default, and kind of the way that it works is that it goes clockwise. It rotates clockwise. The opposite direction, though, is you can give it a negative radian value, and it will go counterclockwise. So on here, there's also this rotate. It shows how to do it. But again, that's kind of a little bit clunky, so try to avoid that if you can. As it did with the translate button, whenever you run draw, the origin and the angle is set back every time, back to the start, whenever it restarts that draw function. Um, this is also additive, so that means you can keep kind of going in a circle. And for those of you that maybe just completed um, the spiral, this one actually could have helped you potentially a little bit. That one was hopefully you were able to get that. So let's do an example of rotate. So let's leave the size the same, and let's make a rectangle that is 55 by 0 by 30 by 45. Let's rotate pi over 6 amount, which is 30 degrees. And we're going to fill it. Let's make it green, 0, 255, 0. And let's make another rectangle. That way, this we can kind of see what the difference is. Let's do the same numbers, 55, 0, 30, 45. That way we can kind of see that it's no trick. So if I push that play button, you can see that that green rectangle is rotated. It's skewed, it's turned, and all we did was used a rectangle. But because we did that rotate, it rotated everything clockwise. Okay, now hopefully you're starting to see, okay, this can be pretty handy. And you could potentially like put a negative in front of this and it would change things. But at the same time, whenever you're in the middle of a program and you're doing something kind of specific that you need to go in and do certain translations and rotations and scales, but then you want to come back to where you were and then continue the rest of your program. So maybe you have multiple objects being drawn, but they all rotate and they scale and they do all these kind of types of things. You need to be able to reset back to default or kind of go back maybe to the previous setting. Um, and what we can do is we call what's called a stack. And what this actually is a matrix. I mean, so we use the term post matrix and pop matrix. And this uses what's called a stack feature. To think of a stack feature, think of a set of cards that you have on the table in front of you. You have an option. You can either put a card on top of it, and you push the card on, or you can pop it off, and you can look at it and you can kind of see kind of what it is. And the kind of catch to this is it uses what we call last in first out, and so the last item put on, the last person the push last thing put on is going to be the first thing removed. So you can't kind of be like go back. Oh, I'm going to like take out these in front of it, underneath it. You can only kind of put on top of the stack, or you can only take off the top of the stack, and you can only look at what's on that top card. Hopefully that makes a little bit of sense. Uh, it, it's pretty it can be a little bit confusing until you really start kind of thinking about it. You can almost kind of think about like if you set your hands in front of you right now and you stack your like right hand underneath your left hand. If you try and you can't lift up your right hand because your left hand is sitting on top of it. But if you take off your left hand, then you could pick up your right. Hopefully that helps a little bit and doesn't get you super confused. Definitely feel free to ask your teachers for some clarification if you need a little bit on that. So, push matrix puts a copy of your origin settings on a stack, which saves the old settings. Then you can change the origin and new objects can be created. Later in the program, the pop matrix resets the origin to the previous settings without affecting the objects that are already drawn. Um, so you can have a lot of layers of the origin on the stack by using the push matrix multiple times. Uh, every time you do a push, though, there needs to be a pop. You kind of have to match them up like you match brackets in the program. So every time you push, there should be a matching pop so that then you can kind of go back to it. So let's try this code. This code's a little bit complex, so I'll kind of go with you guys on this one. So size, I'm going to leave, well, I guess on this one it says 200, so I'll do what yours should look like scale-wise at least. So let's do a fill of 0, 0, 255. Do a rectangle that is 0, 0, 50, 30. Push matrix. Now what this really is doing is this is saving. It saves the origin settings. And why that's kind of important is we want it to save at the default because like that's kind of the best place to be. I'm going to give it an extra space in here because we're going to make a change. And so we're going to say translate 70 0. This expects there are two numbers to be put into it. Translate. This is 70 to the right, down 0. Let's fill this with 0, 0, no, 255. This one's green. 0. Then let's make a rectangle of 0, 0, 50, 30. And let's do another push matrix. What does that tell me? At this point, I need to do 2 pops. Let's translate again. Now remember, translate is additive, so we're going to add 0 going to the right, and we're going to go 100 down. And let's fill this. Let's make it yellow, so that's 255, 255, 0. And let's make a rectangle that is 0, 0, 100, and 50. Okay, let's pop our first matrix. So let's fill. And let's make this one red. 255, 0, oops, comma 0, semicolon. And then let's make a rectangle that's at the origin. And we're going to make it kind of small, 45, 15. And do one final pop. And let's fill this, and we're going to make it purple, so red, no green, blue, and make a rectangle at 0, 0, 30, 30. Okay, so if we run this, you should get something that looks like this. And really kind of what's happening here, and maybe you can see it, maybe you can't, is we draw the blue box, then we move over and we draw the green box, then we go and draw the yellow box, then we go back up and draw the red, then we go and draw the purple-y pink type one. So to kind of help visualize the whole, oops, maybe you didn't see that. So here's what it looks like. Now, hopefully, and to help you kind of see how this looks, things that you should kind of notice is, and this kind of helps with the stack contents. And maybe doing your comments with this might be helpful as well, so definitely feel free to pause. Our stack currently holds kind of one. Whenever we first start off, our stack doesn't have anything. The blue rectangle is up here in this corner. Why? Because that's the default. Then we save that default location. We go 70 to the right, draw a green rectangle, and we save that we went 70 to the right. So our stack, instead of having an origin of 0, we have origin of 70, 0, and underneath that we have an origin of 0, 0. We translate down to 100, and we draw the yellow rectangle. We don't add a new stack yet. We don't add a new stack at all. Then we pop the matrix and return it back to where it was before we went down 100. We were at 70. We were at that. This is the last save location. And we draw the red rectangle. Then we pop again, and we wind up at the origin because that's the first place that we put the push matrix. Okay, so in this example, the origin was translated to the center of the whole thing, and that's kind of where we push it to, is we push it to the origin, and we run through it over and over again, and we actually wind up popping it so that then it comes back and it works out well. Definitely feel free to try this specific program out. This is an example of it using scale. And in processing, if you go to the reference, there is kind of some more help that you can have with those different things. So here's your program. Here's your assignment. Create a piece of art. And art at this point in time is pretty much kind of whatever you want to do. But you need to use a basic triangle, ellipse circle, and rectangle squares. For each part, have at least translate, rotate, scale, and a push and a pop pair. Be creative. Use color. Try some new stuff. Check out the processing webpage for things like how to round a corner or how to do a partially filled circle. So submit the assignment as assignment 14-1, at least for my class. Check with your teacher if you have another numbering system. As always, make sure you zip that folder. If you don't remember how to do that, you can go and check out the how to zip a folder video that was made. As always, happy programming.